Excuse me, sir, has there ever been a robbery at this establishment?
Not that I know of. I don't know.
Mom?
No, Mom's boy.
Okay, you need to share. Sharing is caring.
But I don't care.
If you stop fighting, I'll give you a treat.
Are you talking to me? No!
Think you're a boss, huh?
I mean, I love our chances. You know, it's been
What a reflex. That was really amazing, wasn't it? 2.5 if-then statements and deductive reasoning. If-then statement is just that. There is an if, there is an and. So there are two examples here. If the team wins the semifinal, then the team will play in the championship. Another if-then statement is, if I pass my driver's test, then I will get my driver's license. And in an if-then statement, the sentence that comes after if is a condition, it's a statement, and that statement we call hypotheses. It can be an assumption as well. The statement that comes after then, we call that conclusion. So basically we're saying, given the condition that the hypothesis happens, we can draw the conclusion. That's what the if-then statement does. Next, deductive reasoning. Deductive reasoning uses facts, definitions, laws of logic to make a logical argument. How do we know that? We have to prove it. In geometry, we're going to learn how to make proofs, which is a very important concept and skill to learn in geometry. Very often, you also hear inductive reasoning. Now, deductive reasoning, statements made via deductive reasoning, because you have proof, it follows a certain pattern. It never changes. There's no counterexample. It is always true. Inductive reasoning is not as disciplined. Inductive reasoning is just a statement or a conjuncture formed based on your previous examples and patterns especially. So if you see something happens all the time, you can draw the conclusion, right? So you can say, every Friday, I go out to dinner with my family, or every weekend we go out for a hike. Now, every now and then, I'm sure your family doesn't go out on every single Friday. It doesn't always go out on every single weekend for a hike. So there are exceptions where there are counter examples to that statement. However, if you use inductive reasoning, because you go out to dinner every Friday, I can probably reasonably assume and say that your family will go out to dinner this Friday. So that's inductive reasoning. I have no proof. I have no logs and records. I don't follow you. But, it's not the tightest argument. That's the difference between deductive reasoning and inductive reasoning. Here's one. We already did this one. Identify the hypotheses and the conclusion. If I pass the driving test, then I will get my driver's license. My hypothesis, like I said, always follows the word if. So I pass the driving test is my hypothesis. And my conclusion is I will get my driver's license. Okay. Next example. Rewrite the statement as an if-then statement. So let's look at A. Every game on my computer is fun to play. So can I say if what? If the game is on my computer, sorry for the chicken scratch, then it is fun, or the game is fun to play. Right? The next one says, I will buy the CD if it costs less than $15. They did all the job for us. I already have an if statement, so simply copy it down and say that if the CD costs less than $15, if the CD costs less than $15, then I will buy the CD. Buy the CD. You can tell that it's still an old textbook, that you guys don't even listen to music on CDs anymore. When I was in college, everybody was listening to CD, and that was the biggest revolutionary compared to the tapes. Time has changed. Laws of logic. One of the laws is called the Law of Detachment. And let's read this. It says, if the hypothesis of a true if-then statement is true, then the conclusion is also true. It's almost like a tongue twister. Basically, it's saying when you have the if-then statement, notice that you have two parts. Law of detachment has two parts. That's the easiest way to identify it. And then it's saying if the hypothesis is true, then the conclusion would also be true. Okay, so let's think about an example. Say if a person, all teachers have teaching certificates. So if you have obtained a math teaching certificate in New Jersey, then you can teach in New Jersey, right? So if Ms. Burge has a teaching certificate in math, and because that's true, then the statement, the conclusion that I can teach in New Jersey is true. So it's that simple. So again, if the hypothesis is true, then the statement is true. That's law of detachment. And there are two parts when you talk about laws of detachment. Law of Syllogism says that if the statement P, then Q. So if I simplify it, it says if P, then Q. And then if Q, then R. Then if P, then R. Okay, so if the statement P, then statement Q, if statement Q, then statement R. Therefore, I can I can connect the two together by stating if statement P, then statement R. So one example is, so let's say if the first statement, if it continues to rain, then the soccer field will become wet and sloppy, right? So my P is it continues to rain. My Q statement is the soccer field will become wet and sloppy. Then I further can state, if the soccer field becomes wet and sloppy, then the game will be canceled. So in the second statement, my Q is the soccer field becomes wet and sloppy. My R is the game will be canceled. So I can combine the statements by saying, the conclusion is that if it continues to rain, which was my original P, then the game will be canceled. If it continues to rain, then it will be canceled. Okay, so that's one example. Let's look at another example. If, let's see, if the bank robber steals the money, then the sheriff will track him down. If P, then Q. Then if the sheriff tracks him down, then the bank robber will be arrested. And so if Q, then R. Therefore, I can also say if the bank robber steals the money, then the bank robber will be arrested. So that's that's basically almost like a transferring kind of concept. If one thing happens, the next thing happens. If the next thing happens, then the third thing happens. And then you can say if the first thing happens, the third thing will happen. Okay? What can you conclude from the following true statements? If you wash the cotton t-shirt in hot water, then you wash and then it will shrink. Then what can you conclude if I say that you wash the cotton t-shirt in hot water? I think this is in your packet. So the solution is that, let's look at the hypotheses. The hypothesis is that you wash, right here, you wash the cotton t-shirt in hot water and then it will shrink. So don't we have right here, this is my hypothesis, right? So by law of detachment, the law of detachment again has two parts. It says if the first thing happens, then the second thing happens. And if this is true, then this would be true. And so in our case, this conclusion is true. You wash the cotton t-shirt, the conclusion that the cotton t-shirt will shrink is true because the hypothesis is true. That's my conclusion, okay? Actually, that's my answer. My conclusion is by law of detachment, the hypothesis is true. Then if the hypothesis is true, then the conclusion is also true. So just copy down the law of detachment. Here's a checkpoint. I want to go through some of this with you. Rewrite the statement as an if-then statement, then underline the hypotheses and underline the hypotheses and circle the conclusion. All teachers at East High School have taught for at least 15 years. So if I have to write this into an if-then statement, I can say if a teacher teaches at East High School, then he or she has taught at least 5 years. That's how I do it. Okay, just use common sense. Make sure the statement is correct. And I'll work with you on number 3. If x has a value of 7, so that's a if statement, then this 2x minus 3 has a value of 11. And then it says the value of x is 7. So what can you conclude? I can conclude 2x minus 3 has a value of 11. And the reason for that is law of detachment. Right? Law of detachment has two parts. It says if this is true, which is what it's saying here, then the conclusion is true. Okay? Points. Use of the law of detachment. Which argument is correct? Explain your reasoning. This is it says in argument 1, if two angles are vertical angles, then they are congruent. Again, here is my hypothesis, and here is my conclusion. This is conclusion. This is hypothesis, right? And angle 1 and angle 2 are congruent. This is pointing at the conclusion. So angle 1 and angle 2 are angles, are vertical angles. What do you guys think about this? Let's look at argument 2. If two angles are vertical angles, this is my hypothesis because it comes after if, then they are congruent. Now, 1 and 2 are vertical angles, so this is directly related to the hypothesis. And the conclusion is related to this conclusion here. So I would say argument 2 is correct. 2 is correct because by way of the law of detachment, it says that if the hypothesis is a true statement, and the hypothesis that is the two angles are vertical angles, right? So if the hypothesis says two angles are vertical angles, if that's true, and then it says that the two angles are congruent. So that's the law of detachment. Again, it's two parts, has an if statement, has an and statement, no more, no less. Now let's look at law of syllogism. If you have many parts, that's more than two parts, that's a good indication that you need to use law of syllogism. Write the statement that follows from the pair of true statements. If the daily high temperature is 32 or less, that's one condition, that could be my P, then the water in the pipe is frozen. So this part is my conclusion, and that is my Q. Then it says, if the pipe is frozen, and this is my Q, but it's a hypothesis, then the pipe will break, and that's my R. So the law of syllogism says, if P, then Q. If Q, then R. We can draw the conclusion, if P, then R. Okay, so my solution is, if, my P is, if the daily temperature is 32 degrees or less, then jump straight to my R, the pipe will break. That's your answer. Okay. Checkpoint, you can finish this on your own. And here's another one. I will try to walk you through this one. Which argument is correct? Explain your reasoning. If two angles form a linear pair, there's my hypothesis, then they're supplementary. Here's my conclusion. Put conclusion in a circle. Okay? 3 and 4 are a linear pair. This is going straight, relating itself to the hypotheses. So 3 and 4 are supplemental, and it's relating to conclusions. Again, it's two parts, and so I would say A is, where 1 is correct, because there are two parts by law of, sorry about my chicken scratch. Let me see if I can do a better job at this. By law of detachment, if the hypothesis is true, then the conclusion is also true. Okay, so that's number 1. Let's look at argument 2. I'll use blue. If two angles form a linear pair, then they're supplemental. If two angles form a linear pair, then they're Actually, I just realized there's a typo here. It's form, F-O-R-M. So now it says 3 and 4 are supplemental. Notice that this is tied into the condition. It doesn't, I can't connect it with my law of detachment, because my law of detachment, the first thing it says is if the hypothesis is true. It doesn't mention anything. It doesn't start with a conclusion. You cannot go into the conclusion unless you have discussed the hypotheses. So right there, I know something is not quite right. And then it continues to say, so 3 and 4 form a linear pair. So it's sort of reversed. There's actually another term for it. It's called converse. We're going to study that later. But for now, argument is not true because we cannot prove it with law of detachment. Okay, so that's it for today. It's a simple concept, but it does require you to slow down, read a lot, and think through it and draw your own conclusion. Finish your packet, and we're getting close to the end of chapter 2 now. Take care, guys.